Okay, this problem is a difficult one because it's got 3 dots. Yeah, well, let's start with the drawing. This is the boat. It doesn't look like a boat, but it's okay. And it's moving on the water 90 kilometers per hour initially, but it cuts off the power, meaning that the engine's thrust is gone, right? So the only force that's acting on this boat is the frictional force, going against the motion of this boat. Boat is moving to the right, while the friction is acting to the left. But how much? Negative 70 V. That's what the problem says. Yeah, the frictional force is proportional to the speed of the boat by this much. I put the negative sign in front because the boat is moving to the right while the frictional force is acting to the left. So you need to put the negative sign in front of the friction force. So let's solve the equation of motion. Let's set up the equation of motion along x. Okay. Well, this thing is, moving to the right, but it's decelerating. It's not accelerating, but accelerating to the negative in the negative direction by a. Okay. ma equals negative 70 v. That's the force. That's the only force present in on this boat, right? No other force. Well, gravity may be acting downwards, normal force are acting upwards, but those are not important in this question because we're only looking at the motion along the x direction, not the y direction. Y direction is not. We're not looking at the y direction. Okay. Now, m, mass of the boat is 1,000. A equals negative 70 v. So A is negative 70 over 1,000 v, which simplifies a little bit to 7 over 100 v. Now, when looking at this problem, this shape, right, it's not very obvious how to solve the velocity, right? But this, if you remember, acceleration is defined as the time differential, time derivative of the velocity, right? We sometimes write like this. Yeah. So that much this much acceleration is acting on this boat to the left. Okay. So let's rewrite this acceleration A in terms of this, time differential of the velocity. V dot equals negative 7 over 100 v. And by the looks of this equation, I can tell that this is a differential equation, first order differential equation. Ordinary differential equation, ODE. Okay. So there's a set procedure to solve the ordinary differential equation, which is to it over here. Okay, in which we set model velocity function as this: v initial to the power times the exponential function e. Okay, and this differential equation, the velocity decays with time with the exponent of e, and we set something like this: s times t. Okay, set. Yeah. If we set the shape of the velocity function like this, we are able to solve this ordinary differential equation. Okay. Why? Well, you see why. Do you remember how to take the first order derivative of exponential function? For example, do you know how to do this? d dx e to the kx. It's k e to the power of kx, right? This k pops out, as a result of differentiation. Right? The same thing happens here when taking the derivative with respect to time. Okay? What comes out is this s, negative s, will pop out. Therefore, time first order derivative of v with respect to time will result in negative s vi e to the negative st. Okay, this thing comes out. This negative s comes out of the. Okay. Now let's plug this original function and its derivative back into the equation here and here, right? And see what happens. Okay, so on the left side you see negative s vi e to the negative st equals negative 7 over 100. I'm writing the right side. And now v is given by this model function vi e to the negative st. Right? Okay. Now what can we do? Well, we can divide, we can slash off some terms, from both sides of the equation. vi is gone. You can divide both sides of the equation, by any numbers as long as you do the same operation on both sides of the equation. Vi can be cancelled out. E to the negative st can also go on. Can also be gone, right? Because you can divide through both equations. So what we are left with here, what we end up getting is that negative s equals negative 7 over 100. So we've found the value of s, 7 over 100. Okay. Therefore, we found how the velocity develops with time. Well, it doesn't really develop, it actually slows down. Okay, well, let's put this s back in here. V is vi. Vi is the initial velocity. Okay, which is 90 kilometers per hour. Okay. E to the negative 7 over 100. Our S itself is now 7 over 100, right? So that's why you replace the S with 7 over 100 times t. It's a function of time, so, okay. Exponential function of time. Yep. And we know when t, this is a function of time, when t was 0, you put 0 in here, then what happens? E to the 0th power is 1, right? So it's VI, becomes VI, and that was 90 kilometers initially. So initial velocity 9 kilometers. So we found a general form, general solution for this equation of motion, which is 90 to the E times E to the negative 7 over 100 t. Okay. Now, it's asking, okay, let me erase this again here. Question is asking, find the time required for the boat to slow to 45 kilometers. Okay, so this value is now 45 after some time. After some time, we need to find this t that makes this v 45. Okay, so let's plug in 45 in the v. Okay, equals 9t to the power of negative 7 over 100 t. Our job here now it's clear. Find the t which satisfies this equation. Okay, how do we find this? Well, we take the logarithm. Okay, well, first let's move all the constants to the other side. Okay, divide both sides by 90. We'll get 1/2 equals e to the negative 7 over 100 t. Okay, and excuse me, let me put more space in between. You see what I mean? What I did over here? I just divided both sides by 90. So this is gone, this becomes 1/2. Right? Now, what I want to do here is take the natural log on both sides. ln. ln is the log with the base number e. Okay. By doing this, this side will become negative 7 over 100 t. Right? If you remember the property of the logarithm. Yeah. If you don't understand it, please review the logarithm. Logarithmic property. And we need to evaluate this one. This one, log of 1/2 is how much? Well, we can use calculator. But anyway, natural log of 1/2 equals this thing. So we can find t. How much is t? T is equal to, we just divide just both sides by this. So negative 100 over 7 times natural log of 1/2. Okay, this is the result. And let's compute that in a computer. Okay. Yeah. Well, negative 100 over 7 times natural log, where's that? Oh, ln of 1/2. Yeah, I got 9.90210. One more decimal to follow, but you round to the nearest tenth, maybe. Yeah. So 9.9 second. Okay, that's it. Thank you.